looking at the algebraic equation y squared plus z squared is equal to x squared, and I'm thinking to myself, that looks kind of circle-like. Y squared plus z squared is equal to r squared. Usually you see x squared plus y squared, but you know, x squared plus y squared is equal to radius squared. You need to be able to think outside of the usual x, y, z order. So thinking of y squared, or thinking of y and z as your first two variables, and then x, thinking it as a radius parameter. That's a nice way to identify that you're looking at an equation whose solution set is, well, it has something to do with a circle. Let me try to verbalize what it has to do with a circle. The intersection of the solution set to that algebraic equation with the x is equal to a plane, and here I'm saying that x is equal to a, where a is a real number. So x is equal to a. You could think of as an algebraic equation in three variables, and its solution set is, well, hey, my pen's down here. It's the yz plane, without coming out towards us at all. And the intersection of the solution set to that equation with the x is equal to a plane looks like this. The set of ordered doubles yz in R2 that satisfy the condition that y squared plus z squared is equal to a squared. And here a is a number. Now this equation here is a circle of radius, absolute value of a. Remember, a could be negative, so I've defined this set to be c subscript absolute value of a. I was thinking circle of radius a. So I said, since c subscript absolute value of a, this set, I gave it a nickname so I didn't have to write the whole thing out again. Since it is a circle of radius a, and I just don't know what else to say, so I started drawing. I am looking at various x is equal to a planes first. X is equal to 0, that's the zy plane. So in that plane, just the point 0, 0 works, right? 0 squared plus 0 squared is equal to 0 squared. So when a is 0 over here, I get a circle of radius 0. And that's a single point. And then I was looking at the x is equal to 1 plane, so that would put a 1 squared right there. Y squared plus z squared is equal to 1 squared. That's the unit circle. So I started drawing a few points that are going to go on my unit circle over there. Let me round that off. That'll go around the back, so I'll make that broken. And not my best forethinking here, but all right. That's kind of circle-like. Then what? Come up another 1. That brings me to here. You know, I think I see what's going on. The circles are just getting bigger. You know what? I hate this drawing. Going back, let's see if I went to right there, then I draw a unit circle again. And what's happening is I'm going from 0 radius out to some bigger radius right there, and it's happening again as I go this way, but man, the picture's just not working out. So the radius gets bigger and bigger and bigger, and radius gets bigger and bigger and bigger. So out here I should be drawing a big circle there and a big circle there. I think I know the problem. The perspective is wacky here, so let me try to change things around so that the x-axis goes up and down. I have better, you know, the symmetry. This thing is a cone. This thing is going to be a cone, a whole bunch of, yeah, a circular cone. Gets bigger and bigger as it goes out in either direction. And I have better luck drawing those things when I draw them like this. The axis of symmetry, so the center of the cone, drawn vertically. So I'll do that, and then I need to draw some coordinate system that has both x, y, and z in it, but agrees with the right-hand rule. So what do I have to do? If I'm going to get x and y to be z, so x and then y direction towards me would be z to the side. Okay, so y here and then z to the side. That's a right-handed coordinate system, so that's allowed. And in the floor, right, in the x is equal to 0 plane, that's the floor, I have a point, I go up to here, and then I have the unit circle Ah, yeah, and then going around the back, I can make a dotted line. So there's a unit circle going up to 2. I have the circle of radius 2. Maybe that guy was a little bit too close. I'll have to do this. And then dotted lines around the back, but at least I can make a nice extrapolation like that. And missed. There we go. I'll make extrapolation going the other way. Try to make it look like that doesn't line up as well as it seems to. And then draw another circle down here, somewhere down there, for a negative x coordinate. That would give us still a positive radius. So this thing is most certainly a cone. And the solution set is a cone. Not just a cone, is a circular cone. Okay, and I guess both these drawings are relevant. I mean, the other one's really a complete mess up. This one's just sort of ugly, and that one's good. So I'll keep them both. It kind of looks like that X is part of my sentence now. I can't stand it. I'll clean that up. I might have bad handwriting, but I try really hard to communicate well.